Hello, everyone. My name's Riley Dickens, and I'm a consultant with Encryption Consulting. Today, we'll be learning about the products and services offered with Thales's Data Protection on Demand and how to integrate one of those tools, the HSM on Demand, with a Docker container. Thales's Data Protection on Demand, or DPoD, offers enterprises a number of different data protection tools and services to choose from. These include HSM on Demand, centralized key management, policy management, and usage reports. These services can be chosen by the enterprise at will, integrating with on-premises, hybrid, or cloud infrastructures. Thales's DPoD lets users protect data of many different types, including payments and transactions, personal data, big data, and Internet of Things devices. The multi-tier, multi-tenant architecture that Thales's DPoD is built on fully segregates each tenant from each other. This architecture also leverages hardware security modules, or HSM technology, which ensures only administrators who have been authenticated can access key materials. The data centers storing these data protection tools and services are all certified to industry security and privacy standards, meaning your enterprise will have no issue meeting compliance requirements. Additionally, Thales's DPoD also offers high availability, scalability, and disaster recovery, not to mention encryption of all traffic in and out of the solution. Now that we know the different services and products offered by Thales's DPoD, we will take a look at one specific product, Thales's HSM on Demand, and how to integrate it with a Docker container. We have two different scripts that will be used in this demo, a Docker file and an installation script. These two scripts will help make this process quick and easy. Our Docker container will work on CentOS, but if you wish to run it on a different distro, you will need to modify the installation and Docker scripts. Both install scripts can be found in the description below. Now, we'll move on to the demo section of this video. For this to work, you should already have Docker properly downloaded and ready for use. If you download the two scripts, you should have a Docker file and an install.sh script. The Docker file needs no change unless you plan to use another operating system. If you're using a different installation media, unlike mine, which is the tar file with a minimal installation for client version 10.2, then you'll need to change it to the proper name on lines 9 and 10. No other changes are needed on this Docker file. In the install script, however, you will need to change line 1 to the client name you wish to use. This can be any name that uniquely identifies the device you're registering. The username and password will be used to connect to the HSM. Keep in mind, you will be prompted for a password during the installation process. After changing these fields, we will begin the integration process. To begin, we will build the Docker container. First, ensure you're in the directory where you want your Docker container created, as well as where the scripts are located. Then, we will run the command docker build period, which signifies the current directory, -t, and then the name of this container. Mine will be named dpod in Docker. The Docker file will now run and create our Docker image. It may take a couple of seconds. After the creation is complete, we will check and see if the image was created. To do that, open a PowerShell window and run the command docker images. This shows all the images created. As you can see, my image, dpod in Docker, is right here. Now to open and run this container, run the command docker run -it, your image's name, --name, and then your image's name again. Now, we have a shell we can use to interact with the Docker container. First, we'll change into the directory we mentioned in our installation.sh file. So that will be cd/root /luna-docker. Next, we will set the environment variables for the container. This is done with the command export cryptographic configuration path equals $home in all capitals /luna-docker /config. So this is a configuration path where the cryptographic.conf file lies. Now, we can run the install script, which is located here as well. We run this install script with /install.sh and follow the prompts as they appear. Here, we'll enter yes. Now, I must enter my HSM password, and then I must do it again. For this integration to fully work, we must SSH into the server itself. This is done by providing the same username and hostname provided in the script. So if we look into the install script, this is the username and hostname you provided. Using these two and the password, we will log into the HSM. So we will do SSH username @hostname. Here we provide the user password, and there we go. Now, we have to register the client we will be using. To do that, we run the command client register -client, the client name provided in the install script, -hostname, and then Docker Luna demo again for mom. Now it shows client register successful, and all that's left to do is assign a partition to the client we just registered. So we type client assign partition -client, then the client name, -partition, and then which partition you want to assign it. As you can see, this is the partition I will be using. This will say client assign partition successful, and this finishes the process of registering the client. Now, we can check if the client is properly registered or not. First, we exit and then cd into the Luna client folder. From here, we can run the command /VTL verify. This shows all the HSMs we are clients of with partitions assigned to us. We can also run /LunaHSM and see that the HSM is coming up when we run LunaHSM. Now it's showing different components of the HSM, such as the serial number, firmware version, and more. If you would like to configure Java and use LunaHSM to create keys in Java keystore, then you'll have to go to the Java folder and make changes to the java.security folder. This is located in the directory /user/lib/jvm/java. Here, you will enter /jre/lib/security. In this folder, you can edit the Java security file I mentioned earlier with your choice of editor. To do this, you simply add the value security.provider.10, or whatever the next number is for you, equals com.safenetinc.luna.provider.lunaprovider. After this, we save the file and then we copy a few files from the folder we were previously in. The files we need to move are the lunaprovider.jar file located in /root/luna-docker/luna-client/JSP. Right here, you can see that lunaprovider.jar file. The other file we need to copy is the liblunaAPI.so file, which is one level lower in /JSP/64. This will be copied to the Java folder, and you'll now be able to create keys in Java Keystore. Check our description below to view our video on how to integrate LunaHSM with Java Keystore. That's the end of our video for today. Thank you for watching. If you have any questions regarding this integration process, or any questions relating to encryption at all, please visit our website at www.encryptionconsulting.com. I hope you enjoyed, and if you did, please like and subscribe below. Thank you.